Welcome to part 2 of Precalculus 3.3, finding zeros of a polynomial using long division. In this part, we'll take a look at 2 examples of finding zeros of 4th degree polynomials having real zeros. Okay, this example problem says find all zeros of this function. As you can see, this is a 4th degree function. Given that this function has a 0 of -2 with multiplicity of 2. So several things that we know, that if the degree is 4, then it has a max of 4 real zeros. All right, and we can also see here that we have a 0 of -2 with multiplicity 2. So that means that implies that we have a factor of x opposite sign 2 of multiplicity 2. Okay, so we know all these things. We also know that if x plus 2 squared is a factor of this function here. Now let's square out that x plus 2 so we can get it in polynomial form. So I'm doing some distributing here and combining like terms. All right, so my factor is now in polynomial form as opposed to factored form. All right, so now I know that. So I know that this is a factor of this polynomial. Now what we've learned already, if this is a factor of this polynomial, if I divide the polynomial by this factor, I should get a remainder equal to 0 because this polynomial divides evenly into this function. So I can set that up. Okay, so I made some room and I set it up. So I know that if I divide my zeros, so this is, I remember we started out with a 0 of x plus 2 and we squared it because it has a multiplicity of 2 to get this form of our 0 of multiplicity 2. And I say that if I divide it into here, I should get a remainder of 0. And what you have left up here as your quotient should be another factor of this polynomial. So let's go ahead and do that. So I'm going to ask myself, what do I have to multiply x squared by to get x to the 4th? So that would be x squared. So x squared times x squared is x to the 4th. X squared times 4x is 4x cubed. X squared times 4 is 4x squared. Oops. All right, I'm ready to subtract. Okay, so I'm going to subtract. So I've got 0, I've got 8 minus 4 is 4x cubed. 23 minus 4, 23 minus 4, that's 19. X squared, bring down my 28x. And now I'm going to ask myself, what do I have to multiply x squared by to get 4x cubed? So that would be 4x. Write it up top. 4x times x squared is 4x cubed. 4x times 4x is 16x squared. 4x times 4 is 16x. I'm ready to subtract. All right, so I get 0. 19 minus 16 is 3x squared. 28 minus 16 is 12x. Bring down the 12. Now I divide again. I ask myself, what do I have to multiply x squared by to get 3x squared? That would be 3. 3 times x squared is 3x squared. 3 times 4x is 12x. 3 times 4 is 12. So we can see if I subtract this here, we're going to get 0. So that tells me that this being a factor divided into this evenly, which is indicated by getting a 0 remainder. So that means this times this gives me this. So I can rewrite that. All right, I rewrote it. So my original function is equal to our divisor, d of x, times our quotient, up here now, here it is, plus remainder of x, which in our case was 0. All right, so I've rewritten my function as two factors multiplied together. Now what I do know already is this here function, we know its factored form, this factor I should say, its factored form was x plus 2 squared, or you could call it x plus 2, x plus 2. This is my 0 of negative 2 of multiplicity 2. Oops. Wait a minute. Let's make that right. So this is 0. So multiplicity 2. So remember, I can have 4 real zeros here. So there's 2 of them. So that means this other factor must give me the other 2 zeros. So I first want to check and see if I can factor it. So I've got a 1 and a 3. So 1 times 3 is 3. So there's one way to multiply to get 3. And those two numbers will add up to give me my middle number of 4. Since I have a leading coefficient of 1, I don't have to factor by parts. So my two factors are x plus 1 and x plus 3. So there's my other 2 zeros from here. So I've got another 0 of negative 1. And I have another 0 of opposite sign, negative 3. Okay, so I rewrote my function f of x in factored form. X plus 2 times x plus 2 I wrote as x plus 2 squared, then x plus 1, then x plus 3. So some questions will ask you on this assignment to write the polynomial in factored form. So this is how you would do that. This is how you would write the polynomial in factored form. Now, one other thing is that when you have to do a problem such as this on a quiz, you would not be able to get into the graphing calculator, Desmos graphing calculator, and just type this function in and pick the zeros off as your x-intercepts. You could see that these are whole numbers. It'd be fairly easy to take those off of Desmos, but we're learning how to do this analytically using the methods that I'm teaching you that are mostly based on polynomial long division and knowing the relationship between zeros and factors. Okay, here's our final example here. Once again, we're given a degree 4 polynomial, which means the maximum number of real zeros is 4. All right, we're only dealing in real zeros in this unit. Okay, now we're given some information here. We're told that f of 1 is equal to 0. All right, what that's telling you is that x is equal to 1 is a 0. And we also know from this other statement that that x is equal to negative 3 is a 0. Okay, so we need factors in order to divide. So x minus 1 is a factor, and x plus 3 is also a factor. All right, so what you want to do next is multiply those two factors together to write it in polynomial form. So I'm going to distribute this out and combine like terms. So I've got it in polynomial form. And what I do know is if I divide by this would be my d of x, I should end up with an r of x equal to 0 because this is a factor. It should divide evenly into f of x and leave you with a remainder of 0. So we've seen that several times. So let's try that. All right, I set it up. Now let's do the division, and we're expecting to get an r of x is equal to 0. So I ask myself, what do I have to multiply x squared by to get x to the 4th? So that would be x squared. X squared times x squared is x to the 4th. X squared times 2x is 2x cubed. X squared times negative 3 is negative 3x squared. Now I subtract. So I get 0. 6 minus 2 is 4, so this is 4x cubed. Negative 17 plus 3 is negative 14x squared. Bring down the negative 56x. All right, so we're going to go through the division again. What do I have to multiply x squared by to get 4x cubed? So that would be plus 4x. So I've got 4x times x squared is 4x cubed. I have 4x times 2x is 8x squared. I have 4x times negative 3 is negative 12x. Subtract. So this is 0. Negative 14 minus 8 is negative 22. X squared. Negative 56 plus 12. Negative 56 plus 12. That is negative 44x. Bring down the 66. All right, and then we divide again. So I ask myself, what times x squared would give me negative 22x squared? So that would be negative 22. Negative 22 times x squared is negative 22x squared. Negative 22 times 2 is negative 44x. And negative 22 times negative 3 is a positive 66. And that looks good because that subtracts to 0. So we've reinforced the idea that x squared plus 2x minus 3 is a factor of this 4th order polynomial because the remainder is 0. And this is, if this is a factor, then this is the other factor. All right? Okay, so I wrote it down here. So instead of writing out that whole 4th order polynomial, I just wrote f of x, so I had room. So the 4th degree polynomial is now equal to this factor here times this factor, which is the quotient here, plus r of x, which we said, of course, was 0. So we don't need that. So now from here, we should be able to get the other two zeros. All right, so this one here, we know already was x minus 1 times x plus 3 because that's what we started out with. So this is x is equal to 1, of course. This is x is equal to minus 3, so that's 2 zeros. All right, so degree 4, so we need 4 zeros total. So this piece over here, this factor is going to give us the other 2 zeros. Now you can see that that's not going to factor because 1 times negative 22, you're not going to be able to add to get positive 4. So we're going to have to use the quadratic formula here. So let's write that out. So we're going to have our other 2 zeros are going to be negative 4 plus or minus the square root of b squared minus 4ac, all divided by 2a. All right. So let's carry that out. So that's negative 4 plus or minus the square root of 16 plus 88, it looks like, divided by 2. So that's equal to negative 4 plus or minus the square root of 104 over 2. All right, so let's branch out. Let's see if I have some room here. Let's do it over here. Branch out 104 to reduce it. So that's 252, 26, 13. So that means I'm going to take 1, 2 out and leave 2 times 13 underneath, which is 26. So I've got equals to negative 4 plus or minus 2 root 26 over 2. Let's cancel, cancel, cancel. So this is equal to negative 2 plus or minus root 26. So that leads me to my other 2 zeros. My other 2 zeros would be negative 2 plus root 26 and negative 2 minus root 26. All right, so there's 2 zeros and the other 2 over there. Okay, so just to summarize, we started out given a function of x, seeing that it's a degree 4 polynomial. We know that we can have at most 4 real zeros. We know, since I told you, that we're dealing in real zeros on this unit. We're also given that f of 1 equals 0 and f of negative 3 is equal to 0. That tells you that x is equal to 1 is a 0 and x is equal to negative 3 is a 0. That tells you that x minus 1 is a factor and x plus 3 is a factor. So you take those two factors and you multiply them together to get a larger factor. Okay, then that is what you're going to divide into the 4th degree polynomial to get this factor here. All right, you expect to get a 0 remainder because we know that x squared plus 2x minus 3 is going to go in evenly to this function because it's a factor. All right, so once you have the quotient on top there, that's your other factor. All right, that's this factor here. So this factor that we multiplied out started out to be these 2, and from there, these are your 2 known zeros from the given information. Now when you go ahead and try to find the 2 zeros from this factor that we determined from the quotient, we decided that it wasn't factorable and that we had to use quadratic formula to find those 2 factors. So we carried on with the quadratic formula, get all the way down to these 2 x values. These are the zeros that we got using the quadratic formula. We simplified it branched it out. Remember, when you're asked for exact solutions, they're going to be either whole numbers like these or combinations of fractions, whole numbers, and radicals, but they will not be rounded decimal numbers. All right, so that about covers what we need to be able to do in section 3.3. Let me know, as usual, if you have any questions about the material. Make sure you get an early start on this, since, as you can see, this is a lot of writing to carry out this long division. And make sure that you're not taking shortcuts by using Desmos, because you need to be able to show me that you can do this analytically. All right.